Hello everyone. Now I would like to tell about Z language and aspect-oriented software. Let us know introduction about Z language. Z is not a programming language and it is not a method. Z is a formal notation based on discrete math and the predicate calculus. The predominant foundation of modern mathematics used in Z is Zermelo-Fraenkel set theory. It underlies every branch of mathematics. The famous scientist Mike Holloway quoted that software engineers want to be real engineers. Real engineers use mathematics. Formal methods are the mathematics of software engineering. Therefore, software engineers should use formal methods. The history of Z language is Z was originally developed by Abriel in 1977 with the help of Steve Schumann and Bertrand Meyer. Abriel has said that Z is so named because it is the ultimate language. Although the name Zermelo is associated with the Z notation through its use of Zermelo-Fraenkel set theory. Z specification language is based on typed set theory. The most widely used formal specification language is Z language. It is built upon schemas. Schemas are basic building blocks. It allows modularity and it is easier to understand by using graphical presentation. The language of Z specification is grounded in mathematics and we will give you a description of world in terms of mathematical objects. We know that object is a real world entity. So we describe that through Z language. We describe what objects exist and how relationships between them may be made into specifications. The problems in software development. Here we are observing specification, construct, program. What to do and how to do it. What to do is telling specification and how to do is telling program. How to ensure that S is not ambiguous so that it can be correctly understood by all the people involved. How can S be effectively used for inspecting and testing P? S and P are nothing but specification and program. How can software tools effectively support the analysis of specification, transformation from specification to program, and verification of program against specification? These are the problems normally we undergo in software development. This is the diagram. We are observing the problems were happening in software development. In analysis technique, we come under simulation, testing, verification, and runtime monitoring. Let us know about simulation. Simulation means constructing a model of an existing system to be studied or a system to be built and then executing actions allowed in this model. The model can be a physical entity, example, scale, clay model, or a computer representation. And let us know about testing. Testing is a technique for detecting errors or problems in implemented software, hardware, or non-computer systems. It consists of executing or operating a system to be tested using a finite set of inputs and then checking to see if the corresponding outputs or behavior are correct with respect to the specifications. Now, coming about verification, it is the procedure of confirming that software meets its requirement. In other words, it means checking the software with the admiration to the specification. And real-time monitoring. Apply your final software in a real-world input data. Example, beta release software. The major goal of software engineers is to develop the reliable system. But how software engineers develop reliable system? We have to develop the formal methods. The formal methods can be derived from mathematical languages, techniques, and tools. They are used to specify and verify systems so that engineers can construct the reliable system, a mean to examine the entire state space of a design, whatever hardware or software, establish a correctness or safety property that is true for all possible inputs. For example, if we have a problem, that is either the fuel filter is clogged or the fuel pump is defective, but you just replace the fuel filter, so you know the problem must be with fuel pump. Either it is the fuel filter or it is the fuel pump. So by using the formal methods that are mathematical techniques for developing computer-based software and hardware systems, in computer science and software engineering, formal methods are a particular kind of mathematically based techniques for the specification, development and verification of a software and hardware system. Here we are observing that the fuel filter or is the fuel pump we analyze easily through mathematical notations. By observing here, we are understanding that this is a problem with fuel pump. So it is easy, we can detect the problems by using formal methods. Here, see the formula of formal methods. Formal specification, also called as formal notations, plus refinement plus formal verification, that is logical calculus. Using a language with a mathematically defined syntax and semantics, the properties are functional behavior, timing behavior, performance characteristics, and internal structure. Formal methods for specification of the sequential systems are S, constructive jet, VDM, large. States are described in rich math structures that are set, relation, and functions. Transition are described in terms of pre and post conditions. Now I am going to tell about aspect-oriented programming. Currently, the dominant programming paradigm is object-oriented programming. It has been presented as a technology that can fundamentally aid software engineering. It is reflected in the entire spectrum of current software development methodologies and tools. Object orientation is a clever idea but has certain limitations. Coming to limitations, we observe what they are. First of all, what is object-oriented programming? Programming methodology that modularizes code into objects. What does it do? Aids programmers in separation of code into real-world objects. There are so many advantages of OOP. Modularizes code into real-world objects, so it is easy to understand the code. Code is reusable if modularized correctly. Code is easily maintained due to fix once, use everywhere principle. Many development methodologies lend themselves to OOP. Now, let us see about aspect-oriented programming. Programming methodology that modularizes codes into processes. What does it do? It also aids programmers in the operation of concerns or processes, specifically cross-cutting concerns, as an advance in modularization. Coming to AOP terminology, advice. What is an advice? It is an injected code. Join point, it is a point of execution. Point cut, it is a point of injection. Aspect means advice plus point cut, and weaving is a process of injection. In this diagram, we observe the terminology related to AOP. It is advice, it is point cut, and these are all join points, and this arrow showing program execution. The AOP implemented languages are ActionScript, C or C++, COBOL, PHP, Prolog, Python, etc. These many languages are the implemented languages of AOP. Object-oriented programming and aspect-oriented programming both have some similarities. They take the advantage of code modularization and code reusability, code maintainability. And coming to differences between AOP and OOP are OOP modularizes on the basis of real-world objects. AOP modularizes on the basis of processes or functionalities. What is the need for AOP? There are problems with traditional objects-oriented programming approach. OOP divides processes into classes or objects. These classes often cross over into many different processes. It leads to duplicated code, and it also hard to maintain code and hard to use the code. The advantages of AOP are currently with OOP implementation is forced on developers. Developer must implement requirements ahead of time. Often time, developer is not clear on requirements upfront. Problems solved by AOP are implementation can be held off until clear. Bad implementation is eliminated due to unclear requirements. Here we observe that AOP key idea. In yellow color it is showing base or core program, and these are the aspects. We both view them and final system is made. Conclusion. AOP modularized implementation of cross-cutting concerns, and it is easier to evolve system, late binding of design decisions, and more code reuse. If software system comprises of cross-cutting concerns, consider learning more about aspect-oriented programming. Thank you.